Hi everyone, welcome to my YouTube channel. I am Lisha, studying in Sri Venkateswara College of Engineering. I am here to explain about the topic dearrangements. Nothing is in its right place. From the subject DMS, that means a discrete mathematical structure. Its code is DCS405A. Introduction. Definition. A dearrangement is a permutation of elements in which none of the elements appear in their original position. Historical context. Studied since 18th century by Perry Raymond de Montmort. Symbolically, if is the number of dearrangements of objects, then counts of permutations with no fixed points. Application. Cryptography, probability puzzles, computer science. Nothing is in its right place. As we can see in the picture given, a dearrangement is a permutation of objects, number of objects in the original position. That is, n is equal to pi of 3, 1, 4, 5, 2, etc. Formally, that is equal to I for all I. Mathematical formulation and dearrangement examples. Dearrangement formula: inclusion, exclusion. Dn is equal to d factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on till 1 divided by n factorial. Recursive formula: d of 0 is nothing but 1 d of 1, that is equal to 0, and d of n, that is n minus 1 d of n, d n minus 1 and d n minus 2. Approximation: d of n approximate n factorial. Sample values: so d of 0 is nothing but 1, d of 1 is nothing but 0, d of 2 is 1, d of 3 is 2, d of 4 is 9, d of 5 is 44. Interpretation: rapid growth similar to factorial but scaled by 1 by e. For example, 1, 2, 3, 3, 4 gives 2, 4, 1, 3, 4. N of 1 CB is not dearranged, which is a dearrangement. Geographical representation: graph showing the growth of dn compared to n factorial. Observation: dn is equal to n factorial. Visual comparison of fixed point versus dearranged permutation. Chart showing dn by n factorial approaching 1 by e. Dearrangement in probability. Problem: what is the probability of that no letter is placed in its correct envelope? Formula: p of n d of n n factorial, as n is infinity and p of n is 1, that is similar to 0.3679. Intuitive explanation: random permutation tend to misplace item. Real world applications. Secret Santa problem: no one draws their own name. And seating arrangement with constraints. Watching problems in algorithm. Cryptographical suffering. Error checking system in software testing, etc. Dearrangement variants. Partial dearrangements: some elements may be fixed. Restricted dearrangements: some positions cannot be receive certain elements. Involution permutation equal to their inverse. Connection to permutation with specific number of fixed points. Algorithmic implementation: Python pseudocode of computing dn. Def dearrangement of n If n is equal to 0, then return 1. If n is equal to 1, then return 0. Otherwise, written n minus 1 into dearrangement of n minus 1 plus dearrangement of n minus 2. Time and space complexity application in stimulation and randomization of randomized algorithm. Conclusion summary. Dearrangements provide deep insights to probability combinations and randomness. Importance demonstrate surprising results like limit to 1 by e. Dearrangements show up natural in wide variety of combinational problems. The recurrence and approximation reveals deeper mathematical structure, useful in analyzing real life constraints with fixed position must be avoided. Understanding the dearrangements can help build stronger algorithm for matching the shuffling. Encourages crucial thinking about probability in everyday context. Thank you for watching my video. Please like, share and subscribe to my channel.